Today we're going to be wiring up a analog control on a Watson-Marlow case drive pump. We're also going to be wiring up a leak detector. Since I don't have a leak detector today, I'm just using a contact closure. And as I engage the contact closure, that would be the leak detector saying you have a leak. So normally the NEMA module would be mounted as such using, I believe, 6 screws like this. So when you're getting ready to wire up your analog control and leak detector, you would have to remove the NEMA 4X cover. You would also have to remove the glands that are here, and they come in American sizes and metric sizes right here. So you would remove this, remove your NEMA module. I've already done that. By the way, when you're removing the screws on the NEMA module, just remember that they're non-captive screws, so they will fall on the floor. So make sure of your surroundings so you don't lose the screws. So once the screws are removed, you're exposed to the NEMA module. One thing Watson-Marlow does well with their NEMA module is the circuit board itself is all labeled. So where we're going to be working today in reference to the NEMA module is we're going to be working on this terminal block here and this terminal block. This terminal block is for your leak detector, and this terminal block is for your analog control. So in this particular case, the leak detector, we have 2 wires, one going to ground and one going to IP. And basically when you engage the switch would engage the leak detector to tell you have a leak. For the analog control, I've wired up the analog control to 0 volts and IP. And basically 0 volts would be your 4 milliamp control, and your IP would be your 20 milliamp control, or the plus. So as I mentioned, the terminal blocks that we will be working on today is, what's it called? Looks like J9 for the leak detector and J5 for the analog control. This is J9, this is J5. So you get your precision screwdriver and you would insert your wires for your control, the ground and the IP for the leak detector, and screw it in here and mount it, and then fish your wires through the gland in the back. Same as your analog control, ground and plus on your J5 going to your 4 milliamp to 20 milliamp connection, and route them through the gland. After you're done that, you could go and reinstall your NEMA module as such. For demonstration purposes, I haven't run the wires through the glands. I'm just going to leave them out here temporary. So after they're wired, what you need to do is, again, the switch was already pre-wired, as you can see here, and I've wired the switch, this particular switch, to ground and to positive. And as I switch the switch, I engage the leak detector. For the analog control, I have this analog generator. It's from Precision Digital, and as you can see from this one, I have power going to the 4 to 20 milliamp generator, and then I have a negative and positive going to, in this particular case, ground and milliamp output. Negative being black and red being the milliamp output. Alright. So in this particular case, The ground is actually black, which is on the blue wire of my wiring connection, and the plus signal would be generated on the red, which you now see here. So now my 4 to 20 milliamp generator is on. So as I said, you would wire up your NEMA module and then put it back together. I'm just going to put one screw in for demonstration purposes, and you would line up the gasket, make sure everything's lined up. And wire up your 6 screws. Or sorry, screw in your 6 screws. And normally the wires would be coming out of your glands here.